Welcome to Azal Engineering YouTube channel. My name is Kidan Amaram. In the previous tutorial, that is tutorial part 1, we have seen that how to model, analysis and design mat or raft foundation. Today I will show you how to calculate number of reinforcement and spacing, plus how to do the detailing of a mat foundation in Autocad software. Watch this video up to the end since the last point is a game changer. Subscribe my channel and share this video to structural engineers, site supervisors, contractors, civil engineering instructor and students, plus clients who need a structural plan. Let's dive into the video. First of all, it's better to go to your SAFE version 21 software like this. In the first tutorial, that is tutorial part 1, we have going to model, analysis and design our mat like this. So you have to take some reinforcement data. To do this, it's better to go to display menu. So show a slab design. After that, it's better to make layer A. So the maximum reinforcement area for X direction, that is the top reinforcement area, is 169.53, and that of the bottom area of reinforcement to the X direction is 469.32 like this. So it's better to record this data to the Excel sheet to calculate the number of reinforcement and spacing of reinforcement. After that, I will show you all the detailing parts like this. It is not the final output. We will do all the reinforcement details together. I will show it later, so it's better to go to record our data. So the maximum area of reinforcement to the X direction, that is the top area of reinforcement, is 169.53. So you have to record your data as top area of reinforcement in X direction, that is the maximum area of reinforcement, 169.53, and that of the bottom area of reinforcement to the X direction is 469.32. Have to record it 469.32. I will check it again. Yeah, 69. Okay, that is good. So I will change the direction to the Y, that means to B direction, and I will record the data also. To do this, go to display, show slab detail. So I have to change only this to layer B, make it okay. Area of reinforcement to the Y direction, that is top, is 190.94, and that of the bottom area of reinforcement to the Y direction is 646.16. So I will record this data. So 190.94 to the Y direction, that is 190.94. This is area of reinforcement to the top direction, and that of area of reinforcement to the bottom direction. I will record it again. So that is 646.16. 646.16. After this, I will calculate diameter of reinforcement and number of reinforcement plus spacing of reinforcement. To do this, first it's better to take the maximum value to the top from this to this, from Y and X direction. This is because to be more safe than to become economical, but you can use this area of reinforcement detail to become more safe and safe. But first of all, rather than economy, it's better to use safety. So it's better to use the maximum value to become more safe. So to the top direction, I have a maximum area of reinforcement when we compare to the x and y direction. It's better to use this maximum value, which is 190.94. So I have to calculate number of reinforcement and spacing using a 1 meter strip width. So to do this, first you have to divide. You have to know what is the AS or area of reinforcement value to diameter of 10, 12, and 40. To do this, area of reinforcement for diameter of 10 bar is that. I will do this here in this space. So pi times d squared, that is 3.14 times d squared is 10 times 10 divided by 4. So have to use a bracket here. It's better to use a bracket here. So make it okay. So area of reinforcement for diameter of 10 is 78.5. I will resume this to the other data. I have only changed diameter of reinforcement to be 12. So for reinforcement bar, that is 12, you can use area of reinforcement 130.04. So for area of reinforcement diameter of 14, it's better to use like this. That is 154. Averagely 154. So at the top, reinforcement area of reinforcement, this divided by the area of bar, which is, it's better to use diameter of 10. So if you divided area of reinforcement from your design to area of reinforcement to bar, you have to get a number of reinforcement like this. So you have to use 3. If you divided this 1 meter width to 3 area of reinforcement, you have to get your spacing like this. Your spacing like this, but your spacing is it's better to compare with this data, that is from 200 millimeter, and maximum area of maximum size of aggregate, which is also averagely 200. If you have to use aggregate number 02, so it's better to use diameter of 10 with spacing of 200 millimeter for top area of reinforcement. For the bottom direction, I have to use the maximum in here also. So the maximum area is, I have to edit from this. So the maximum area is 646.16. So if you have divided this value, you have to get 8 number of reinforcement. So it's better to change number of reinforcement to 12. So I have to get 6 total number of reinforcement 5.716, averagely 36. So from this you can calculate that spacing within 1 meter width. Have to use 6. So our reinforcement spacing is 160. If you have to compare it with this parameter, so it's better to use 160. So area of reinforcement of 12 with 160 millimeter spacing. So all the data is do like this. After that, the rest one is additional reinforcement. That is additional reinforcement for the maximum span. That is for the bottom. It's better to use around the column, and for the For the bottom spacing, it's better to use around the colon, that is from the center of colon. You have to use up to L/3. I will show it in detail on the AutoCAD software. And for your top reinforcement, it's better to use around the mid-span. So I will show it in detail. So these additional reinforcements are reinforcements to the maximum movement condition. So you can use a minimum reinforcement here because we have to use the maximum reinforcement detail. So it's better to go to your AutoCAD software to do the detail. So the top reinforcement in X and Y direction is diameter of 10 to 200 millimeter spacing. So the top reinforcement, this is a mat foundation detail to the top one, that is a mat depth from your design, that is 750 millimeter with scale 1 to 25. So all the spacing is put like this, and the section that is around this point to up and down. So the section shows our depths of mat and that of the depths of lane concrete like this. So the top reinforcement is put like this to the X and Y direction, and that of the bottom reinforcement is put like this. I will show the bottom reinforcement here. So the top reinforcement looks like this. So I will show it in detail. So the top reinforcement to X and Y direction. This is to Y direction. That is a diameter of 10 to 200 millimeter spacing within the total length, that is top, including the anchorage length, that is depths divided by the concrete spacing, that is 50-50 millimeter to the both sides. We have to get 650 anchorage lengths. You can calculate the anchorage length exactly. I will show it in the next tutorial. So all the reinforcement detail to the top to the Y direction is like this, and I have to replicate this. And first, before replicating this, I will put also your reinforcement detail with the spacing and total length like this to the X direction. After that, it's better to replicate to all spacing that to the contractor understand the detailed drawing. It's better to replicate, and I will show the additional reinforcement where you have to put your additional reinforcement. So from here, it's better to put near to the column because the additional reinforcement is here in the mid span. So I will put all the spacings. So to the Y direction, it's better to put like this. And also to the X direction, our top reinforcement is replicated like this. I will show all things in detail. So it's better to put it around this area because the mid span is for the additional reinforcement detail. This spacing is the L/3 value, so it's better to put your top reinforcement to the X direction like this. So you have to use this total spacing and divide it into 3. So you have to get this value. After that, if you measure all this dimension is total dimension divided into 3. So it is equal in dimension. I will show it in detail. So total length is divided by 3. You have to get this equal value, this average equal value. So this total length is divided into 3. So our reinforcement detail is put like this. So the additional reinforcement for the top one is put around the mid span. This is because our movement looks like this. I will show it. So at the support, our movement is maximum around here and become I will draw it. So our movement around the support become this. It's curve actually, but I will draw it to show for you, and it become down around this and become maximum like this, So I will repeat it up to the end, becomes this, like this, like this, like this, etc. So at the mid span, it's better to add some reinforcements like this. I will show it also on the safe software Autocad. So our movement is converted like this. So you have to around this is maximum. So it's better to do additional reinforcement to the top to the mid span, and for the bottom around the support. So I will show it on reinforcement detail in practical way. So the reinforcement detail to the x direction, the additional reinforcement is put around the mid span like this. So it's better to change the color to show for you. I will use another color. So make it green. It's better to use, okay, it's better to use cyan color for the additional reinforcement with the minimum reinforcements of diameter of 10 with 200 spacing. So I have to put up to the dimension for this reinforcement is from here to here. So you can add some direction like this. So for this reinforcement, it's better to use direction like this. Direction from here to here. So our additional reinforcement direction is starting from here to here. The maximum span for your, make it off. Okay. The additional reinforcement is from here to here. So I have to use this method, and it's better to copy this data to the other reinforcement detail by clicking around the mid span. So our reinforcement detail for the top looks like this, and I will add to the y direction. So your reinforcement detail to the y direction is like this. You have to add only the spacing and total length. Okay, so it's better to change the color from here to here. So the additional reinforcement to the y direction have a length of half L over 3 span of the total length. So you can get the spacing by minimizing this value. So up to this. So you can copy all this data to any place to show like this, and also around this, and etc. You can do like this, all the reinforcement detail like this. After this, we have complete the top reinforcement detail like this, and you can add some notes around this you can show the top reinforcement detail around this. So the negative, all the reinforcement detail is put like this. You can section around this to show more additional data. So you can do the reinforcement detail like this. For the bottom reinforcement detail, we will do it again. So for the bottom reinforcement detail, our additional the main reinforcement area is diameter of 12 at 16 millimeter spacing. So go back to your Excel template that we have converted the reinforcement detail, that is diameter of 12 within maximum spacing of 160 millimeters. So it is correct. So I will replicate this to the both y and x direction. So you can replicate it. I will cut my reinforcement around this. This is because maximum reinforcement length is 12 meters. So you can cut your reinforcement. If it is above 12 meter, make it ortho. So copy all this to the mid span. This is because around the colon you have additional reinforcement to both y and x direction. That is minimum reinforcement. So it's better to copy all the reinforcements to x and y direction at the mid span. This is because to clearly show for contractors and the labormen. So at the construction stage, they can easily understand the detailed drawing. So all the reinforcement to the main reinforcement to x and y direction is put like this. I will show the locations of the additional reinforcement. As I told it before, the locations of additional reinforcement to the bottom. This is the bottom reinforcement for IMAT within thickness or depth of 750 millimeter. So I will show you all the additional reinforcement is at around the column. So it is around starting from here to here. You have to put your additional reinforcement. I will show it on the mid span. It's better to show your on the mid span. So your additional reinforcement to the y direction is starting from here to here. So the additional reinforcement is put like this. I will change the color also, the color like this. So the additional reinforcement is around this. So for the top span, the span around this is starting from here to here. You can calculate or you can minimize your concrete cover. So our reinforcement detail, you can measure all the detail and you have to use a diameter of 10 to 200 millimeter spacing. That is the minimum spacing. So all the reinforcement, the additional reinforcement detail around the column for the bottom reinforcement look like this. You can copy it to all the data and the reinforcement to additional reinforcement to the along to the x direction is at the around the colon. So you have to put around this. So it is up to from here to here. So I will change the color to easily visible it. So the reinforcement maybe a diameter of 10, minimum reinforcement to the minimum spacing. So have to change all the reinforcement like this. Sorry, like this. And you have to copy it to the other one I told you. So easily you can detail your drawing like this. So all the top and the bottom reinforcement detail is put like this. You can add some additional notes around this. You can show all the top reinforcement and the bottom reinforcement in the section menu also. So these were the most important part regarding to detailing of mud or raft foundation. In the next tutorial, I will show you how to model analysis design in detail, isolated footing, combined footing, strap footing. I hope this video is helpful for you. Please like this video and subscribe my channel to get a new updated video daily. See you in the next important video. Thank you for watching.